Okay. Uh, Welcome to this nuclear energy virtual conversation workshop hosted by the Global America Business Institute. Good morning, good evening, good afternoon, wherever you are in the world. Happy Earth Day. I know there are a number of different discussions and events going on right now, concurrently or a bit after. So hopefully we can contribute to the festivities of today. My name is Alan On, Director of Programs and Communications for the Global America Business Institute. Thank you for joining us today. As was the case with Gabby's webinar last week on international regulatory harmonization, international coordination on opportunities for early deployment demonstration, we will be ambitious in the scope of issues we intend to cover today. Are there tensions between innovation and deployment, commercialization considerations? Are there tensions between or among criteria that we would like to see in future nuclear reactors or energy systems? What other industries, case studies, historical experiences do we need to look at and study more closely as a guide or a model for the future nuclear industry? Would like to formally introduce our panel today. First, we have Brett Kugelmass, Managing Director of Energy Impact Center. We have Dan Yerman, who is author and founder of the nuclear energy blog, Neutron Bytes, of which I'm a big fan. And then we have Alex Gilbert, Project Manager at Nuclear Innovation Alliance, or NIA. On a more personal level, would like to thank Alex for joining us on relatively short notice. Gave him a call last week. Appreciate the work that he's done at NIA and think that his perspectives would be invaluable to this conversation. Years ago, Brett, around the time that he established Energy Impact Center, would bring the whole gang over to Gabby roundtables and workshops that we hosted when things were in person. So always appreciate that support for our work and our activities and considering us a resource on these issues. Around the same time, Dan, who is based in Ohio, would always email me and ask me if there was a live stream or a dial-in number for the events that we would host, to which my answer was generally no. Now everything is virtual, so that's not really a problem anymore. So it seems that we've come a long way since those days, and now you're all presenters, panelists in the Gabby forum, Gabby event. So perhaps this was destiny all along. So our agenda today will be a bit of a departure from our general practice. Most of this conversation will be done in a fireside chat format instead of formal presentations, remarks. Nevertheless, we'll still be giving our panelists a couple minutes to introduce their organizations, their work, and projects of relevance to the issues of today before I start grilling them with provocative questions. So Brett, let's start with you, and thank you all for joining us today.
Yeah, Alan, thanks for having us. I missed the in-person events, the sandwiches, the chips, the cookies. I wish I could have done it this live in person, but I can't wait till they start back up again, and you better believe that we'll all come for them too. So thanks for hosting those, and thanks for hosting us. Yeah, just a little bit about me. I come from a former career as a technology entrepreneur. Came to DC to work on the climate and energy challenges, and started the Energy Impact Center as a vehicle to do so. Very quickly, we arrived at the conclusion that nuclear not only was absolutely essential, but was just like the linchpin, absolutely critical technology, towards achieving our global clean energy goals. And yet, the whole industry is just stuck in this stagnated position. And that became clear where the real opportunity was for us to make a difference. And so our organization just became totally dedicated towards understanding the challenges and opportunities within nuclear energy. We started the Titans of Nuclear podcast as a way to do that. That's probably how most people know me, as the host of that podcast. I've interviewed over 1,560 people in the last 3 years, 1560. The first year we did 865. We have 300 of those conversations now live online. And after about a year or so, we started to catch on to certain themes and learnings from these episodes. That's when the impact part of the Energy Impact Center, really started kicking off. Was we took those insights and learnings from those conversations, and we started launching real-world projects to make a difference, based on what we were hearing from the experts themselves. So I can get into some of those learnings later, but a lot of it culminated in basically us understanding that there was a need not for the advanced reactors, not for the Gen 3 plus reactors, but just the good old Gen 2 reactors, right? That's when most successful builds have ever been accomplished. The first 50 in this country reactors that we built were some of the best performing. They were essentially all first of a kind, all a little bit different. 26 of them are still running today, and they all outperform every other energy source that mankind has ever created, period, end of story, including newer reactors. And yet nobody was offering that. So early in 2020, just before COVID hit, we launched the public release of the Open 100 project. That's open-100.com, which essentially is a reference plant design for a Gen 2 reactor wrapped in a modern power plant. And so that's what my organization has been just totally focused on. This is non-proprietary information. It's for the public good. It's complete engineering schematics and economic workups, construction schedules, everything that a utility would need to just go and build a Gen 2 reactor, which is how they used to do it and how we had the cleanest, cheapest energy mankind has ever seen. So that's really the focus of our organization today.
Thanks, Brett. Dan, if you could introduce your work, especially your work through your blog, Neutron Bytes.
Thank you. Can you hear me?
Yes.
Okay, good. I'm Dan Uhrman. I publish the pro-nuclear blog, Neutron Bytes. I've been publishing it since 2007. In 2020, the blog had over 300,000 page views. Just under half the readers are in the US. The other half are in more than 80 countries worldwide. A little bit about me. I worked at the Idaho National Laboratory in Idaho Falls from 1989 to 2009. And the majority of my time there was in technology transfer and commercialization of new nuclear technologies, which is what I'm still very interested in. My focus in today's webinar is on the concept of speeding up time to market for advanced reactors and SMRs using reference designs and standards. And the heart of my message today is if the global response to climate change and the need for decarbonization of major industrial and transportation sectors that use electricity is to build hundreds of large and small reactors. They can't be stick-built one at a time like the US did in the 60s and 70s. My response to that is if there were detailed reference designs for advanced reactors and SMRs and standards developed around them and integrated into the development process, it would boost the confidence of potential customers and, more importantly, investors that the developers have a sound basis for their efforts. Reference designs are not new. The US railroad industry did it 2018 to 2021, coming up with about a dozen different designs for steam locomotives in order to move material for the war effort. And over almost 4,000 locomotives based on these designs were built between 1918 and 1945. So the US has done this with a major industrial sector and probably could do it again. The problem is the current state of play for the development of next generation reactors is it's kind of a cottage industry. And there's a whole bunch of people out there. If you look at Canada, there are 13 SMR developers, all with unique designs. Canada only has a population of 33 million. So obviously these guys are looking at export opportunities. So globally, the question is, where's the supply chain going to come from if every one of these guys has their own particular take on what it takes to build a nuclear reactor? It's not going to work. So the way I think the startup landscape needs to change is that, of course, they're going to have to build and test prototypes, but every one of these designs, if it had a detailed reference design of some kind, Brent's on the right track there with Gen 2, a reference design, as a kickoff point, a lot of the complexity might be removed from the process of getting a product to market in less than a decade. That's my shtick.
All right, thanks so much, Dan. Alex, if you could introduce NIA and some of the recent work and reports that you guys have been doing of relevance to today's discussion.
Yeah, of course. And thanks so much for inviting me, Alan, and to Gabby for hosting us. So the Nuclear Innovation Alliance is a nonprofit think and do tank that focuses exclusively on advanced reactors. We are primarily funded by foundations interested in dealing with climate mitigation. So we do work very closely with industry, but we kind of have some ability to, I think, do independent analysis that is appreciated by congressional, executive, and regulatory audiences. So we have done a number of things that relate directly to this question. One of the most, I think, high level was a report that we did on SpaceX. We specifically were looking at the aerospace sector in the context of the commercial cargo program, which was a public-private partnership to develop capabilities for NASA to deliver supplies to the International Space Station. And that was a very successful program overall, although the competitor to SpaceX in that program ended up not being successful. That program was the foundation for SpaceX to deliver cargo to the space station, and now that's morphed into commercial crew. And so that is a really good example of how a public-private demonstration project has been successful and created demand for a future product. And really, it's kind of been foundational to the success of SpaceX and to help transform the aerospace sector. So we were looking at that primarily in the context of demonstration projects and what lessons can we draw for some of the things like the ARDP. But there are also a number of things that we can learn if we look more broadly at the aerospace sector in terms of what they're doing and how that is kind of really rapidly commercializing and going from what has historically been a government-dominated domain to a new area of economic activity. So we are looking at that for a number of future projects. One other area that we're looking very intensely at right now is regulatory harmonization. So very much appreciate the chat the other week because we are keeping close tabs on all of those events and a lot of that information right now. In addition, kind of looking just at how you'd structure any sort of harmonization between regulators on a national level. We're also looking at other sectors to see what has worked and what has not worked. And so we've looked at the maritime sector, which is kind of unique because they don't really have government as involved. It's done by an independent entity. We've looked at the aircraft licensing and regulation, which I think has generally been a very successful model, though, as I think we can potentially get into, the issues with the Boeing 737 MAX show the potential limitations when you do this type of standardized model across borders. We are also looking a little bit at some other smaller activities. One area that I'll point out in particular has been the FAA overall. And so when we also look generally at how to maybe make the NRC better, we are looking at other regulatory agencies for general inspiration. The FAA has some things that we've seen that we think are really interesting. So one is what's happened with drones. The FAA has done a really good job being able to accommodate a massive technological change in a relatively short time frame. And there's a lot of issues there that completely could transform how we have to manage our skies. And I think they've done a good job of at least initially getting started on that. Another area has to do actually with aerospace and how they've handled regulations for rocket launch and reentry. And so one thing that people don't necessarily appreciate about what SpaceX and Blue Origin were doing is in addition to trying to do this technology innovation, they also have to work very closely with the FAA to rewrite the regulations because we've never had regulations for commercial re-entry and landing of a reusable rocket before. Everything that we've done like that before was done by the government. And so they had to walk a really fine balance of not just doing the technology, but also working with the regulator. So there are a number of lessons that we are looking at. Some we think might be things to avoid. And other things I think we might want to adopt for the sector more broadly. So thanks for having us and looking forward to this conversation.
Thanks so much, Alex. I anticipate that there will be plenty of time at the end of this conversation. We've budgeted extra 15 minutes, as odd as that seems, for on top of the hour. So I think we should have plenty of questions from our attendees at the end of this webinar. But obviously, I will start off with some questions of my own, and perhaps we can start off with the more difficult questions up front. First of all, how do we balance diversity, innovation? Dan, you mentioned that there's 13 some odd reactor developers in Canada. each with their own take of what a future reactor should be, and standardization. How do we reconcile the fact that we have these different developers, the numbers of different reactor companies, and trying to standardize and produce a viable commercial product? Or is the question I'm posing, is that a false dilemma, dichotomy? I think, especially for smaller designs, it would seem imperative or incumbent to standardize and expedite the development of economies of learning, repetition. We had a presentation about a month ago from Milt Kaplan, who discussed this at length with respect to the SMR industry. The theoretical global market for nuclear, overall is massive, but at this stage, just given current market opportunity, industrial manufacturing capacity, what is the best way to proceed? And I guess implicit in that question is, there's an urgency for things like climate change and addressing global poverty, energy poverty as well. So there's not a particular order in which our panelists can chime in on this, but whenever you feel in the mood, please go ahead and unmute yourself and answer.
Alan, this is Dan. I do have some thoughts, and I've been writing about this issue of standardization and reference designs for some time. And I guess I'm going to take a shot at your straw man here and say that I think that the diversity and standardization issue is a false comparison. And the reason for this, that in any technology-led industry, which advanced nuclear certainly is, there's always going to be customized, one-of-a-kind solutions for projects that have unique requirements and for which the customer's needs are not bounded by profitability. A key example is the development by DoD of transportable 1 to 5 megawatt SMRs for tactical readiness power supplies at forward locations. But for customers for whom profitability is a key factor, my hypothesis is that vendors will be forced to limit technological innovation based on their ability to standardize components that can be delivered in volume by their supply chain at competitive prices. I think this is the only path that makes sense, especially for factory production of SMRs. And in that regard, I think light water SMRs will have at least some advantage over some of the advanced designs due to faster time to market and better access to supply chains. No reason by analogy here. Back when IBM first launched the IBM PC, they used an 8-bit bus for adapter cards because there was a robust aftermarket of video cards, modems, LAN network cards, parallel and serial ports, and everything else you could think of that could shove in the PC to make it do more than it was designed to. IBM's competitors, Compaq and AT&T, offered faster PCs with a 16-bit bus, but their market share struggled to have an impact on IBM due to the lack of aftermarket products. And as a result, Compaq was acquired by HP, and AT&T 6300 rode off into the sunset with a couple of large procurements, and that was it. I mentioned American Railroads earlier. I just want to jump into that just a little bit more, but not get too far into the weeds. In World War I, American railroads were not able to pull their weight, literally. The locomotives were underpowered, the freight cars weren't big enough, and the government wanted the railroads to move material to eastern ports to get the stuff to Europe where the war was taking place. The U.S. Railroad Association, standard locomotives and railroad cars were designed by the administration. It was a nationalized effort. A total of 1,900 steam locomotives and 100,000 railroad cars were built in a 3-year period based around standardized designs. And the reason they could do this is because the supply chain could step right up and know exactly what they had to do to fabricate components to build these units. The locomotives designs prepared by the USRA is the closest thing that railroads and locomotive builders ever got to standard types. After the USRA was dissolved in 1920, the designs continued to be duplicated through to 1945. 3,200 locomotive engines of 12 different types were built because the supply chain was there and it was very robust. It's an example of how standardization and reference designs had a major impact on one of America's biggest heavy industries. So I offer that for consideration.
Yeah, I broadly agree with Dan there. I mean, standardization is important, and I do think it's a bit of a false dichotomy. I like that there are so many different designs out there. And one thing I often hear in this industry is, oh, the government should just like pick one and standardize that. And I don't agree with that at all. I think the private sector, each one of them should standardize their design and access a standard supply chain and try to use as many common, industry produced components as possible, but still have as many, different companies, competing for market share as possible. I mean, listen, there were like, a million search engines before Google, and they were all virtually the same, but one of them became the biggest company in the world, or one of the biggest companies in the world. And it wasn't that different than a lot of the other search engines. So you just need a lot of little private experiments to get like just the right model, just the right customer, just the right technology. And then, when we go, to the car industry, there are 5,000 different cars before, Ford, and Ford standardized things, and that one took off. So yes, both diversity in designs and standardization, I think, are both good things.
Yeah, so I'll just build on that and kind of talk a little bit about the timing of how this process will work. And one of the big challenges, I think, is that the stage that we're in right now is focused on demonstration projects as opposed to fully commercialized projects. And one of the challenges I think a lot of the developers are facing is if you're trying to quote unquote standardize a plan, it's not necessarily clear that the current iteration of your design is the best from an economic or other perspective. And so when we're trying to look at how do we go from a first of a kind unit to an nth of a kind unit and develop these kind of standardized processes, standardization might not be for the entire reactor. It could be for specific components, it could be for specific processes. There are a lot of things that you might want to have innovations on. And I think that that is one of the challenges, particularly if you start talking about having a sort of factory construction, is that after a certain point, there are going to be limitations that you introduce when you've settled on a specific design. And that is something that I think you will not be able to know until we get there. And I think that is one of the big tensions when we look at this, is that if we are going to build these reactors in time to mitigate climate change, to be part of the global energy transition, we need to figure out how to get to that standardization as quick as possible. And in terms of diversity, I actually think taking a step back from the technology, I think it's not just a matter of technology, it's also business model diversity. And I think historically, one of the big issues that we've had is that we've been dominated in the US by really one or two major suppliers. And we've also seen that internationally as well. And that's one of the reasons that we've struggled to have innovation broadly in the nuclear sector. And so you want to have an element of diversity and competition, because that allows you to really make sure to weed out any sort of bad business models, potentially technologies. What actually we'll expect is that we'll see some consolidation in the next 5 to 10 years in the sector. And I think that that would probably be good, especially if you have certain companies that are going to be better experts at certain parts of a reactor design. And so trying to figure out that precise balance and that timing, I think, is going to be a huge challenge. And one of the things I think is really important in the near term is microreactors. And I know that a lot of people, I think, in the industry can be dismissive of microreactors because you're not going to have a large scale of climate mitigation from them. But if we build a fleet of 1,000 microreactors, the amount of technological learning and general supply chain development that happens with that, even just the experiences that we gain from that, are things that we can then take and apply those lessons. There can be standardization lessons in the nuclear industry that we could learn from having a large fleet like that. And we can actually get to nth of a kind much quicker. If you actually look at some of the timeframes here with the construction timeframes, once you can get the licensing right, you potentially have a third or fourth or a fifth of a kind microreactor before you get to a second of a kind for most other designs. And I think that if we do those tracks in parallel, this is where the diversity is important. If we have multiple designs that we're pursuing in parallel, there are a lot of synergies that can happen across the board. But of course, the problem there is, do we have enough resources to do that? And I think that that is one of the emerging constraints.
Alex, I think you're dead on there. The only thing I counter with is that you're thinking too small. We shouldn't just have 1,000 microreactors. We should have 100,000 microreactors.
Yep.
Well, Alex, I did see some Twitter conversations that you were a part of, I think last night on cost of nuclear, and you were talking about, for some designs or some projects, there were construction started even before a lot of the design parameters were settled. It seems inexplicable, as you state, but I guess your point about being able to settle on a design to standardize around, that would seem to be a key milestone in this type of this question. Let me go on to the next question. The host of design considerations, things that we want in reactors, safety, obviously, passive safety, walk-away safety, but also, as you talked about, Brett, simplicity, ease of construction, supply chain availability. Other considerations could be back-end fuel cycle sustainability, security and safeguards by design, flexibility in deployment and application. Do you see any pair of design considerations, or perhaps more than a pair, that may pose a dilemma, quandary, may be challenging to reconcile, or perhaps even mutually exclusive?
This is Dan. I'll go with that. I want to focus on the fuel cycle because I think that's the next limiting factor after you address the issue of design. Let's take three leading types of advanced designs: high temperature gas reactors using TRISO fuel, sodium-cooled reactors with fuel in the sodium or heat pumps, and molten salt, fuel in the salt or fuel assemblies. Each of these place demands on fuel fabrication suppliers that are going to be complex and expensive to meet. Now, the government is pushing for demonstration projects with Centrus and X Energy to build, and BWXT, to build the demonstration fuels supply chains. But my concern is that the fuel supplies are going to get ahead of the actual reactors available to use them, which leads to two possibilities. Either the government's going to have to find a way to keep these fuel fabrication capabilities alive until the reactors are ready to buy the fuel, or they're basically going to have to export the fuel to global markets, in which case the government has subsidized their competitors.
Yes, but the problem is that the reactors aren't being built fast enough. It's not the problem that the fuel supply chain is being built too fast.
No, that's exactly right.
Yeah, I think that really highlights one of the things that we're struggling with right now, which is just the timing of all of this. How does all of this play out in practice? How do you actually make sure to balance these things? I mean, some of these are pure chicken and egg questions that we don't really know. How do we start this? How do you actually finance any sort of fuel cycle facility until there's reactor demand? Even if we have some demonstration projects, it's not clear that that's going to be established there in time. And so I think that when we look at a lot of the characteristics that we're trying to put into these reactors, time is probably the number one constraint. I think even more so than cost. I think timing and cost are the two big issues that are really constraining what we can do. But I think a lot of the characteristics that we're designing for, a lot of them are complementary. We look at things like safety or security, to a lesser degree, simplicity and ease of construction. Those are things I think you can actually design in a way that they work together. But the issue is, when you're doing some of these things, how does that impact the timing? Some of these things we actually need more research and development on. And so is that going to be able to happen in a time frame that allows us to deploy that before I think nuclear could potentially lose out in market share? And particularly when you start getting to the cost questions, how does the commercialization time frame look like? Right now, one of the big challenges we have is that we have a big hurdle with the first of a kind facilities. They're going to be very expensive. We're not going to be able to make the case that advanced nuclear is economically competitive with hard data until we get to the nth of a kind units. And whether that happens in, say, 2030 or 2040 is a very different thing politically. And especially because we are still in the early stage, we do need to have political buy-in for a lot of the public-private work that we're doing.
Just getting back to this issue of timing that Brent was talking about, go back to the railroads for a minute. Diesel locomotives were introduced in the 1930s, but the fuel supply for the locomotives wasn't really there. They ran on diesel fuel. The railroads were running on coal and had a huge infrastructure to have coal. It wasn't until the mid-1950s that the efficiencies for diesel locomotives were finally realized, because the fuel infrastructure was finally converted from coal to oil and required new suppliers, new fueling facilities, new technologies, and some of the suppliers were brand new to the industry. It took 20 years for the fuel cycle to change for American railroads, and that's with a technology that arrived ready to go.
Yeah, I mean, this is why my biggest push is that we should just start building reactors, build what we know, and that way you develop a healthy, robust industry that can then start advancing things, that can, put listen, a healthy nuclear industry is going to be printing billions and billions in cash that they can put towards R&D. You know, if you have someone building, you know, hundreds of Gen 2 reactors, they can then afford to build their next gen reactor and the fuel facility to go along with it at the same time. And they'll know exactly what they're doing because they'll be responsible for both. They'll have the money and they'll have the expertise. But we just got to start building.
Well, let me go on to my next question, and this is a question I think you all have addressed to a certain extent already. But you know, with respect to the nuclear community seeking lessons learned from other sectors, other industries, case studies, historical experiences. You know, maybe I can kind of address you individually on this question. Alex, you referenced the SpaceX report. You've done significant research on space applications for nuclear, and you talked about the airline industry, FAA as a model for the NRC, other sectors. What you know, is there anything that you would add on top of you know, some of the things that you mentioned early on? Obviously, you made a very brief statement. Is there anything that you would sort of add on top of that conversation? Any notable lessons learned for nuclear from some of these investigations, research?
Yeah, so I think there are some moderate lessons in terms of regulations for things like maritime or aircraft licensing systems. But I think there's really two major industry lessons that I think are important to draw upon. First, with what we see in space right now, we're seeing a very rapid development of a commercial space industry for the first time. That is definitely happening in the United States, but there are a lot of other companies and countries that are interested. There's this whole new thing called New Space, which has to deal with many different applications of commercial uses in space. And I think that SpaceX has got a lot of fanfare, and they're definitely, they've done a really good job, and they're probably the leader in this new area. But really what they're representing is a break from the old model where you have a small industry with only a few number of actors that's serving primarily a government market. And I think that that's something that we really need to understand when we're looking at developing the nuclear industry moving forward. We really can't put all of our eggs in one basket. We really can't bet on one designer or one business. I think in the United States in particular, we're still suffering from the fallout of the failure of the AP1000 to really be competitive. I think that that was tied to some long-term systematic issues at Westinghouse. When you have a long-term company, especially an engineering firm like Westinghouse or like Boeing, you can see interesting things happen with the company's culture where it's not really going to be a leader of innovation, and it can actually end up becoming so bloated that it's not able to deliver some of this stuff on time. The other industry which I think is relevant here is actually renewables. So renewables, just as a general model, they are much more standardized, and they're not even modular. They're beyond that because they're almost pure standardization. You have a solar panel, you bolt it into the ground, and then you put 100,000 of those together. You have a massive solar farm, and you don't have any kind of diseconomies of scale or growing complexity with that size. And that's something that's been really helpful for the industry. But beyond that, I think the thing that's really interesting about renewables is even with that general modularity or that scalability, the thing that really led to them accelerating in the United States was actually financial innovation. The power purchase agreement model, where you took an energy source that has intermittent production, that you are able to somewhat predict, but you can actually have an idea of how much energy overall it's going to produce, and you can financialize that into a revenue stream, and that revenue stream is guaranteed. That allows you to get a very low interest rate because you're able to demonstrate that you have a sure revenue stream over time. You're able to finance the project, and that's one of the reasons that we're able to build so much of it so quickly. So when we look at nuclear, what we really need to start thinking about now that we've, I think, got the initial ideas of how to develop these new technologies, we're working on how to make the regulatory system work. We need business model innovation more than anything else. I think one of the reasons that everyone's excited about Oklo is because they're trying this build, own, operate model for the first time. Whether that's successful or not, I think you could potentially see that being very successful for microreactors. I don't know if that's the same for larger reactors, but when we look at how to really develop the industry moving forward, we need to figure out this financial question as part of our overall activities on the innovation side, especially in the international context. When we're competing overseas with state-owned enterprises that use the build, own, operate model, plus a whole bunch of other things they're doing on the government side, we need to figure out how to counter that in I think, a very American way, which is a partnership between private industry, the United States government, as well as our overseas allies and our MNCs.
Appreciate that, Alex. Brett, let me pose this question, the same question to you, but perhaps in a different way. You've mentioned that you've interviewed thousands of experts on your podcast, Titans of Nuclear. Congratulations on your 300th episode. Have there been any unique conversations or exchanges that you've had with a prominent expert, as far as offering, a model for the nuclear industry from another area or sector that perhaps that you had never thought before? I know you've derived some broad lessons from your conversations collectively, but just wanted to see if there were any unique instances that you would like to highlight from your work.
Yeah, I mean, one unique instance that I'd like to highlight that I still think I have not convinced the nuclear industry fully of yet, but starting to gain a little bit of support, is stop talking about safety. The reason people are afraid of nuclear is because you talk about safety. The nuclear industry itself is the reason that people are afraid of nuclear. And I cannot drive that home enough. And this will be one of the points that I just keep trying to drive through. I learned that early on from talking to people in the industry, from seeing how perceptions changed over time, from documenting the history of it, from seeing the business model of many nuclear companies today in terms of selling fear, selling out the old systems, and creating this underlying context that nuclear is disproportionately dangerous, which it is not. So, I mean, we can talk about this, ad infinitum. And if you guys have further questions, happy to bring them up. But that is the one lesson that I want to drive home to no end. Stop talking about safety.
That might be an entirely different conversation that we would need to host, but I would say that that topic in general has come up in Gabby forums in the past. If you keep talking about safety, then eventually you get things. Ideas in people's minds. So I'll just leave it at that. Dan, you've mentioned on your blog that you've had reactor developers and companies that will come to you with an aha moment and make essentially changes to their design or their practices, based on a post that you've written. Obviously can't divulge the specifics or the details of these conversations, but are there general lessons or observations that you've derived from these general interactions with your readership?
Well, yeah, sure, Alan. First of all, without divulging anything, the conversation is global. I'm talking to people all over the world. In rough water outside the U.S., I'm talking with people in the UK, Germany, Australia, Japan, India, France, China, South Korea, Sweden, and Finland. One of the things I find interesting is so many readers come from Germany, which is shutting down its nuclear reactors, and from Australia, which has no reactors. It's kind of interesting that with that. Almost all the dialogues via email, and the topics readers are most interested in, and the kinds of dialogues that I have, two major themes emerge since. The first is, what are the technologies that are going to be the fastest in terms of time to market for advanced reactors and SMRs? And in terms of getting these things to market, what has to be done to get them to market in less than a decade? That is just absolutely consistent across all of the dialogue, and everything falls in those two buckets. The other thing is the level of engagement is really important in terms of these conversations. Anyone can read a blog or come to a webinar and listen passively. And my measure of engagement is if somebody takes the time to send a well-formulated question or a correction or a comment. And it's really, some of the stuff just blows me away with how much time people spend on talking about a particular technology or a particular issue. And people have very strong opinions about this. Some of it's driven by competitive desire to look better than the other guy. Kind of have to filter that out. And some of it is just, hey, I've got this idea and I want to kind of share it with you and your readers. So we get that coming up. But everyone's always got an extra tidbit of information that they want to present. What I try and do with this information is keep on focusing not on what happened, but the so what of what happened. That's what readers, I think, are really interested in. Why is this particular development? And Brett, I think, talked about that a little bit, and our Alex talked about this a little bit, which is the build operate model combined from a developer. That's really something that's a huge amount of interest in that, and I think that will continue to grow as a topic.
Perhaps just a very broad final question from me, and this question is inspired from a question that Andy Zach posed last week during our webinar on international regulatory harmonization. He was asking Romina Velshi about, what are the regulators doing, or how do they view advanced manufacturing, additive manufacturing in particular. I would just ask, with respect to advances in that area, how may that challenge current assumptions regarding the need for standardization and the use of established supply chains? Any thoughts on that? Understandably, it's still an area that is the book needs to be written, but just your thoughts about what might the potential be in the future.
Yeah, so that's a really interesting question. I had a chance to visit some of the advanced manufacturing work at Oak Ridge National Lab the other year. And what's interesting is I think that it's not just 3D printing or additive manufacturing that's driving this, it's also other technological development. And what they've done a really good job with is combining machine learning and computer vision. So what they're actually doing is they're able to look at a level of fidelity that we've never imagined before when they're producing one of these parts to see how the actual deposition is going down. And so that, if that goes through all the way and we can actually get that into market, that has a level of certainty and a level of precision that we normally don't have. And that allows you to change all of your estimates in terms of engineering, in terms of even things like safety factors, because you have a much better idea of what that specific part is made of and where it might have specific failure points and what that might happen, might look like over time. What I will say though is that I think it's actually a really big challenge to integrate a lot of those kind of cutting edge developments into at least the first or second generation of the next wave of reactors. Everything that we have right now is actually really 10 to 20 years old in terms of innovations. Even when we're looking at, say, things like developing regulations around this, using methods like probabilistic risk assessment and some of those other computer-based tools, they're really helpful and they're going to definitely allow us to do stuff that we've never done before. But it's still technology that it was originally cutting edge 20 years ago. It takes a long time for some of this stuff to permeate into the industry. So when I look at some of things like additive manufacturing, I think that that could be transformational for when we get to large scale commercialization. If we're in the late 2030s or 2040s, you could actually have that be very widespread and perhaps standard. And so it's really hard to figure out what does that look like in the near term, but that could be one of the things that allows the industry to become very economic and competitive when it actually does matter.
Dan, Brett, any thoughts on this question?
Yeah, I do. If you're going to have standards, you've got to get people to work together. American individualism is a huge impediment, I think, to collaboration, but it's got to be overcome. Of course, American Nuclear Society publishes nuclear standards, but they can't do it alone. You have the NRC, which does regulation. You have at the INL, the National Nuclear Reactor Innovation Center, which does testing. ASME, quality standards for components. The United States Nuclear Industry Council, supply chains, and DOE, which is funding and policy. And somebody's got to pull all these folks together, virtually speaking, get them in a room and agree on how to proceed with standards and reference designs, because the state-owned enterprises do their own internal integration. They have a command and control paradigm in Russia and China, which allows them to beat down individualism. They do it in a way that we don't, our values don't accord with that. But on the other hand, sometimes we go too far in the other direction. And somehow I think we've got to get beyond that, so that the NRC can provide requirements on types and levels of detail and reference designs. The INL can divide methods of test to confirm design details, performance, materials, pressures, radiological protection, and to develop, most importantly, a database of non-proprietary information of testing results. Developers don't want to reinvent the wheel. And if they can go to a database that says these materials operate successfully at this level of heat, all right, in this type of reactor, that gives them some certainty in terms of how they bolt their design together. ASME sets the standards through NQA1 for suppliers, and you have the United States Nuclear Council has a suppliers oriented to try and make the stuff to build these things. And finally, the Department of Energy could play a coordination role in terms of pulling all this together, and also maybe providing some funding, because you're not going to get any of this done without additional money. And I think that would be an important way to get these 5 different stakeholders to overcome their specific kind of stovepipe interests and focus on this issue of getting past the stovepipes and getting some collaboration going in this area.
Thanks, Dan. So I think that's probably enough questions from me. We do have a number of outstanding questions from the audience already piling up. I would just remind everyone, you can submit questions using the Q&A button on the bottom of your interface. If you would like to verbalize, perhaps interact with the panel, you can also raise your hand, and then I can pick on you. We have someone who has raised his hand for some time now, and so perhaps I can unmute him. Give me just a moment. Walter. Are you there? Perhaps whenever you're ready, please go ahead and answer your question or make whatever comment you'd like to make. Walter? He's unmuted, but I don't hear him. Okay.
All that waiting and he missed the shot.
Okay, if we can figure this out, we'll get to him. But I do have some questions already submitted via chat.
Am I there now? Hello?
Walter?
Yeah, can you hear me?
Yes. Hi,
Okay.
Walter. Please introduce yourself, and yes, we can hear you loud and clear now.
Walter Horsting with Business Development International in Sacramento. I've been tracking the TEA group and molten salt reactor teams, several of them around the country. A couple of things come to mind for the industry. One is look at SpaceX with their continuous improvement on their heavy lift rockets. Compare that to NASA's nearly 3 decades of getting the SLS not off the ground yet. So that's the example of, I think, current U.S. nuclear approach versus startup taking it to the chin of the world. Secondly, look at Boeing manufacturing over 1,000 big planes a year that have to fly with better safety than typically any reactor needs to do. And the complexity of a molten salt reactor is much smaller, I would say, by a magnitude than putting together a 777 plane. So there's some real reasons to look at the factory scaling of those solutions. I toss out just a company that I've been following really closely, Seaborg out of Denmark. And they're working on a shipyard power barge approach to fill the far eastern $1 trillion market for coal plants right now. And the closing point is nuclear is 4 times safer than solar or wind per terawatt of power generated. That's my closing thoughts.
Thanks, Walter. Any reflections on what Walter just said? And if not, I can certainly connect. Walter, you can email me if you have any sort of follow-up questions or comments and would like to pose them to the panel. I can certainly connect you via email. I do have a question from, I can't seem to identify the individual here based on what I'm seeing. But let me see if I can wrap this into a two-part question, because they asked two questions. Do you feel that there's a need for an industrial intermediary that specializes in regulatory compliance and licensing in order to allow newcomers to navigate the regulatory environment for licensing and building a first-of-a-kind reactor? And there's also another question asked by this individual. How do you think we should address cost overruns in nuclear builds, based on the fact that companies don't typically make money on the reactor themselves, but on the maintenance and fuel sales for those reactors, over the course of the lifetime of the reactor?
Yeah, I mean, that last part of the question I think is very intelligent. Yeah, the system is totally broken. The main nuclear players have essentially given up on producing a cheap power plant and have relied on essentially regulatory capture to mandate, extremely expensive and cumbersome maintenance requirements, safety inspection, safety analysis requirements. I mean, that's become their business model, essentially, is just keep cannibalizing the existing fleet of the reactors, suck as much money dry of them as possible, instead of building new ones. So I think that was a very intelligent problem that you posed there.
Alan, this is Dan. I think the idea of an industrial concierge function as an intermediary between the NRC and the vendor would be helpful, but something else is equally helpful, and that is what DOE has done with NuScale has gone into cost sharing for the licensing costs. I think the whole model for how the NRC is funded needs to be changed. Investors don't want to go broke funding the NRC's engineers. I think the government should fund the regulatory function 100% to put more money back into development, and just really, I think we've got it backwards as far as that model is concerned.
Yeah, but Dan, the problem there might be the incentive structure. If the government just pays for the regulatory fees, I mean, already the regulators have made a business out of racking up billions of dollars of fees. If now you've got the government purse behind it, why wouldn't it just be even worse?
Well, I think if you extended the cost sharing arrangement to the NRC so that the vendor has skin in the game, then I think that might balance it.
So we do have a name for those two questions. Actually, Scott Nelson from Oak Ridge National Laboratory.
So on the industrial intermediary question, I think it's an interesting idea. What I'd actually say, though, is that you need to internalize a lot more of that than just having someone that can guide you through it. And so there are attorneys out there are consultants out there that you can hire to help you work with the NRC. But really, you need, as a company, to internalize that getting past regulatory review and making sure that you meet all of your requirements and that you have an effective licensing strategy. That needs to be throughout your business model planning. It has to be imbued throughout your engineering team. So ideally, if you were to have a company, you'd want to have a regulatory specialist as well as someone that focuses on the policy side, because there are a lot of other policy questions, a lot of policymaker contact that you have to deal with in addition to the regulation itself. So this is an area that I think is an emerging challenge because there are a lot of new companies and you don't necessarily have the funding for that. And I think historically, because NRC has only had to deal with a handful of nuclear vendors or the operators, which are utilities and are large and have resources, figuring out alternative methods to make sure that there's enough information out there is a huge challenge. And I think we need to figure out how to address that. I'd also say even broader than that, there's an international component of that too. That when you start looking abroad, first of all, you have to figure out all sorts of export and import licenses and get past that. But then trying to license your reactor overseas, that opens up a whole other host of questions. And right now, I mean, the NRC does do international programs, but there's definitely a role for the US to have an expanded presence in international regulatory activities. We could definitely support a lot of the nuclear newcomer countries as they develop their own regulators. And just kind of the idea of making sure that we're being synergistic with our industry, that actually can open up ways for the US government to develop competencies to inform companies that are interested in going overseas to be able to navigate those regulatory systems if we have a hand in shaping those in the first place.
Yeah, the problem though is if we have a hand in shaping these other regulatory systems, we're going to make them mirrored in our own image. And our own image right now is totally broken. I mean, the last 3 reactors that got licensed through the NRC, it cost $1 billion to license. Why does it take $1 billion to prove the safety of a system, of a building that doesn't have anyone in it, right? We build skyscrapers, right, that have thousands of lives on the line if they're built incorrectly. And yet we have regulatory agencies, building departments, fire inspection departments that can do all of the appropriate inspections and certifications for, like under $1 million. And yet a nuclear reactor that has no one inside the reactor room, and when they do melt down, the radiation doesn't hurt a single person, as Fukushima proved, costs $1 billion to regulate. This is crazy. This is what we have to talk about.
I would push back very strongly against that. I mean, whether you are not concerned about the impacts of some of these accidents, the fact is that society has decided that we need regulation of some sort. And so,
of course, I never said we don't need
regulation.
regulation. We need the exact same regulation that skyscrapers have, right? Skyscrapers have thousands of lives in the building.
Yeah, but we've also built hundreds of thousands, if not millions, of skyscrapers over decades. There's a matter of technical competency and experience here, and the issue is that when you're actually looking at having someone review a nuclear reactor, you can't just get a general civil engineer. You can't get even in some cases a mechanical engineer. You need a team of interdisciplinary engineers to be able to review a lot of that. Now, there's definitely stuff that's happening that is taking too long, and there's a lot of duplication. And there was ways that we can make that much easier. And I think that the NRC is respected for its technical competency, not necessarily its processes. And so when we look abroad, we don't necessarily need to export the NRC model because we don't have a model for advanced reactors right now. We're working on building that, and it's going to be interesting to see how that develops. But really, it's the ability to have an independent technical regulator that we want to try and promote abroad.
The NRC has never licensed a single reactor that has been built in its entire history. All of the ones that have been built were from designs from when it was the Atomic Energy Agency, before the NRC was created. And the only ones that the NRC has licensed haven't actually been built yet.
Let me go on to the next few questions, because I think they might allow us to look at some of these issues from a different angle or perspective. I have a question here from Frederick Brim. Which SMR design is likely to be the first to reach commercial operation? Looking at the picture domestically, I mean, that seems like it has to be NuScale. But maybe if we can expand that question to what's going on internationally, what are SMR designs look promising? Designs from other countries, and are there lessons learned to be derived from what's going on in other countries in terms of their industrial arrangements, regulatory frameworks, and things of that nature? Also have a question here from Pedro Camacho. Is there any talk about making regulations more flexible in order to reduce approval costs and first-time deployment times? Agree with Brett that we need to build to find out what works and what doesn't. So, Brett, maybe you can chime into some of these things.
I mean, on the first part, it's like, U.S. SMR companies design reactors, they don't build them. The Russians, the Chinese, they have designed and built SMRs. So something's going right over there, and I think we need to take some lessons learned and figure out how to actually start building them.
Well, the Russian SMRs are coming off of their nuclear icebreakers, and they're downsizing them in terms of the fuel they use from 35% U-235 to under 20. And then their floating nuclear reactor, which they've just deployed, has 2 small reactors. It's a demonstration project. The Chinese have a 100 megawatt SMR, but they're using it to promote geopolitical ends by providing tactical power for tactical readiness on their artificial islands in the Southeast Asia Sea. So it's not a commercial play.
They've got district heating reactors that they're commercializing internally as well now that are SMRs.
I think the only one so far is a demonstration unit, and the HTGRs that they were going to use for district heating have been pulled back because the efficiency isn't there. These were 235 megawatt, two units driving 1 turbine. We're going to be done at Shandong. They're going to build 20 of them, and they've stepped back from that because it's not quite ready for prime time. I think if you want to look at the UK, there's a lot going on there with SMRs, with the government weighing in. And one of the things that's kind of interesting is not an SMR, but a mid-range reactor. Rolls-Royce, which has been building small reactors for the nuclear navy in the UK for many years, and now has a 440 megawatt design, which is a PWR, simple PWR, and they expect to be able to break ground on the first of these by around the end of this decade. What's important for the UK is they've lost some of their big reactors that they were going to build, most notably at Moorside, at Oldbury, and Wilfa. If you take the entire fleet of 440 megawatt reactors that Rolls-Royce wants to build, which is 16 of them, it equals the lost capacity of Oldbury and Wilfa, which went down because Hitachi could not come to terms with the UK over financing. So, and they will build over a longer period, but the revenue stream from the first pays for the second, so forth and so on. So there may be an opportunity not only for SMRs, but more for these sort of mid-range reactors. 440 is more than the threshold generally for SMRs, but they have a couple of things in their favor. Supply chain, experience building these things, and the government may figure, you know what, we'd rather build a string of these 440 ones than put all of our marbles in one boat, which they're doing right in Hinkley Point C, and they may lose Sizewell if the Chinese get irritated enough to walk away because of diplomatic relations between the UK and China.
Yeah, and the mid-sized ones are actually quite interesting, and a lot of lessons learned from there too. I mean, I always come back to Point Beach 1 and 2. Point Beach 1 and 2 are two mid-sized reactors, about 400 or 500 megawatts. Actually, maybe 500 megawatts or a little bit more. Their combined power is more than Vogtle 3. Their inflation-adjusted cost for both of those units built in parallel, $733 million. You get over a gigawatt for $733 million. That's today's dollars, as opposed to the $13 billion spent on Vogtle 3, right? It's just a simple pressurized water reactor built in under 3 years, licensed in under a year.
Alex, any thought on these questions related to SMR deployment internationally and drawing lessons from other countries, especially on the regulatory front?
Yeah, so the regulatory front, I think it's pretty straightforward. Having a performance-based system is preferred to a prescriptive-based system. It's very clear that that is preferred by a lot of the advanced reactor developers. It is more conducive to regulation, and I do hope the NRC does really head towards that. There are a lot of questions about will Part 53 actually realize that vision, and if not, I don't know if we'll be competitive as a regulatory matter. In terms of kind of the development, one thing that I think is important to really think about for the US is that stepping aside from light water SMRs, in terms of advanced reactors, we're actually expecting to see a fair number of microreactors built in the next 5 years. And a lot of them are going to be for government purposes. So there's a high likelihood we'll see a Project Pele. We'll potentially see the Oklo Aurora. We could see the Marble microreactor at INL. We could see the Transformational Challenge Reactor at Oak Ridge. We could see the DARPA nuclear thermal propulsion, so nuclear rocket by 2025. And we can even see a private sector developed space reactor for NASA by 2027. And so when we're looking at how the innovation develops and how do you kind of get the ball rolling and address those chicken and egg questions, those activities combined with the larger activities that we're doing in the US, like the ARDP, the VTR, UAMPS, that can kind of jumpstart our supply chain. And that's really something that we're lacking right now. That's why a lot of these other countries have the ability to very quickly adapt existing designs or pursue new things. They have an experienced group of people that have been building these reactors, that have been designing these reactors, and they have that supply chain. We really have lost that supply chain in the United States. And we can rely to the international market and our allies to a degree. We can work with South Korea, Japan, France, the UK, Canada to help us with that supply chain. But if we're really looking to try and become the nuclear leader in commercial markets in the 21st century, we need to become the dominant supply chain leader. And that's something that we're in the early stages of developing right now. And I think that that is why it's really important that we do as many of these projects as possible, because we'll start realizing synergies on the political side, on the economic side, and on the trade side.
Just to jump in on what Alex just said here, NuScale has gone to Japan for supply chain, has gone to South Korea for supply chain. They haven't gone to US companies. The other thing is that we haven't mentioned the government's huge bet on advanced reactors with the Advanced Reactor Demonstration Program, where 2 advanced units are going to be built out next to the Columbia Generating Station, Energy Northwest, which is one TerraPower's Natrium reactor, and the other is X Energy's XE100. Both of these are highly advanced, unique designs, and the government is going to really put its money where its mouth is to build these things. It's going to be very interesting to see how a supply chains develop around these kinds of designs for this project.
Just drafted a short piece on some of these issues related to supply chains, so perhaps we can interact offline on. Might warrant another discussion, so we'll see. But this next question might actually touch upon this. Question from Rick McLeod. Hi, Rick. Haven't seen you in a while. Heard from you in a long time. He's from the Savannah Riverside Community Reuse Organization. When will the manufacturing industrial complex embrace micro SMR benefits? They also have the capital to invest and be a major player. This touches upon some of the conversation that we just had.
So that's a really interesting question, and I think one of the things that we're seeing is that the initial round of reactor developers, I think, were overly focused on electricity. I think we're starting to see a little bit more focus on other sectors, including industrial process heating, district heating, and hydrogen production. I don't think that that's really the dominant theme right now, but we might see more of that. In terms of the industrial users, honestly, I think a lot of it is just they don't know that this is an option right now. The idea of a microreactor is foreign to them. The nuclear industry talks to itself too much. We don't have engagement outside of the industry with these industrial consumers. One group that NIA has just started working with is actually Google. Google is a leader in this area. They are developing, they're going from their 100% renewables procurement to actually 24/7 carbon-free power procurement. So they're actually trying to not just offset the overall energy consumption they're making with RECs, they're actually trying to make sure that the shape matches as well. And so what we actually could see are the tech companies leading here, which might seem kind of strange considering nuclear does have this social stigma. But if tech companies like Google or Apple or some of these other companies that have big data centers that do need reliable, potentially on-site power, want to embrace microreactors, they're natural first customers. And what we could then do if we have even one or two relatively high profile demonstration projects for that, that will open up the conversation considerably. And that will then potentially have a lot more customers that are interested in this. And part of the issue too is that we need to figure out the timing. This actually might be an area where transportable reactors make more sense. Because when you're building when you have a utility, you're building a big power plant, you're gonna be around for decades. An industrial facility doesn't necessarily have that same type of time frame. You might be around for 15 to 20 years. A company might be hesitant to get their on-site power in the form of a reactor, especially if that does have any sort of concerns about the waste storage on-site being there indefinitely. And so having other sorts of solutions like that, having more options could make it more attractive for certain industrial users.
Just going to Alex's point about small reactors, in Canada, of the 13 reactors, advanced reactors that are in vendor design review, phase 1 and phase 2, with the Canadian Nuclear Safety Commission, 8 of them are focused on process heat for additional revenue streams. And all 8 of them are going to be used advanced fuels. This is my point I raised earlier. In order for them to realize the revenue opportunities of having these high heat output, they are going to want these advanced fuels. And I think the timing of their success is going to be focused on 2 factors. One, can they get the design through the regulatory process? And second, can they get the fuels once they've got the design complete? I should mention that of the 8, several of them are stalled out at phase 1 and have not moved to phase 2. And the 2 that have moved to combine phase 1 and phase 2 are both LWR designs, which is GE Hitachi's BWRX-300 and NuScale, both of whom have moved closer to the end of phase 2. All the others have either completed phase 1 or in phase 1, but none of them have moved to phase 2. So there is an issue there in terms of timing, and you'd have to parse it individually, but it's slower than I think any of us would like.
We're close to the end of our allotted time. I don't think there are any outstanding questions at the moment. So if any of our panelists have any final closing remarks that they'd like to sort of cap off their comments and responses to the questions today, now is the time to do it.
I do have a couple of, I'm gonna go back to my railroads example.
Okay.
We've all talked about supply chains, but going back to World War I, American railroads in the middle of a war effort rose to the challenge of using reference designs, brought design and manufacturing of steam locomotives in the 20th century. So my final point is the example exists from the railroads for the nuclear industry to follow in their footsteps. It's not only a matter of technology, it's also a matter of resolve. That means getting not only our industry to collaborate, but also our stakeholder institutions and the government and in the spaces in between with the national labs. Folks have to work together to make it happen.
And overcoming American individualism, as you
Yes.
said. Brett, Alex, any concluding statements that you would like to make?
Yeah, I just think like the general sentiment, I don't think that we're setting our targets aggressively enough in terms of how many of these we should be building. I mean, the renewables industry had this like 100% renewables thing. Yeah, I just do not understand why the entrepreneurs in this space aren't willing to say 100% nuclear. I mean, you don't have to do it, but that's like what you'd be shooting for. Like, try to convince people that you think you've got the best technology at least. And we should be doing it faster too. These timelines of like late 2020s, 2030s, it's like, why do anything at all? I mean, you're so clearly stating that you're just trying to like get as much government money as possible, never trying to build anything. Like build it now. That's how they did it in the 60s. They did it in just a few years. So just go do it. So those are my final thoughts. Just want to thank you, Alan. Thanks to Dan and Alex. Your guys' insights were awesome. I agree with mostly everything you said. So thank you for being on this panel.
Yeah, I'd echo that as well. This has been very awesome. I do think Brett's point about timing is critical. If you are even looking at some of the political debates right now, there's an emerging question of just, are advanced reactors going to be here on time? Which I think there's a lot of issues with that question. It presumes a lot. But the fact is, when you're looking at what the industry is planning time-wise, commercialization in 2030s and 2040s, I mean, that's a long time from now, and I think that we can accelerate those timeframes a lot. The main issue, though, is that we need resources to do that, and not necessarily from the federal government. I think what the federal government is doing right now, the plans it's supporting are probably there. I think there are things they could do, like maybe move the NRC off the fee model, other areas that they can improve upon. But really, it's the private sector and getting more access to capital. And one of the stats that always just blows my mind: the fusion sector, private fusion sector, has gotten more investment from the private sector than the fission companies. The fission companies have a much clearer path to market. You could actually see them making money in like 10 to 15 years. And so, trying to figure out how to make sure that venture capital and institutional capital is available is really important. I think my high-level point I would want to leave this conversation with is that for us to get to where we want to go, a lot of things need to go right across the board, on the regulatory front, on the government front, but especially on the business front. And we really need to have successful examples. We need to have momentum. And it can take only one or two small things to really put an impediment in front of us. And so I think the last several years have been very exciting. Things are definitely accelerating in the nuclear innovation space, but we need to see that continue, and we need to see that go beyond just, I think, the US and several other countries that are doing some of the innovation. This needs to be global. This needs to be something that we have this as a technology option for most of the world, because the decarbonization challenge is huge. It's going to be fought mostly in countries outside the United States. And a lot of them do not have nuclear as an option right now. And the US can deliver that. The US can make it an option for a lot of those countries, while also having all sorts of economic, environmental justice, and other benefits.
Okay. Well, we are officially out of time. Just wanted to thank all of you guys for sharing the stage to join this conversation for the past hour and 15 minutes. A lot of food for thought that I believe we can follow up on and discuss more, obviously after this panel. If there are any comments, further questions from our attendees today, please email me, and I'll see if we can make the proper email introductions. But again, thank you all so much for your time and all the insights today. Thank you, guys.
Thank you. That was great. Thanks, guys. It was really great talking to you. We should have a road show.
For sure.
Let's talk about that once we can actually get on the road again. Let's maybe do this. Thank you so much, Dan.
Bye bye.
Thank you, Alex.